Hello everyone, welcome to my channel. Today we're gonna looking at a concept that you would definitely be used a lot in your chemical equilibrium unit, and this is the relationship between Q and K. So let's just clarify ourselves a little bit. So what is Q and what is K? So Q means the reaction quotient. And what is the reaction quotient? Well, it is used for in the process reactions when the reaction is not at equilibrium, okay? So just remember this is not at equilibrium, which just means it's temporal. It's not a constant. And in other hand, the K well stands for the equilibrium constant. And this is used for reactions at equilibriums, okay? So this is not at equilibrium, and this is at equilibrium. Okay, and so after we have this concept, let's just dive deep into a question. Okay, so I'll just show you a question and then we can leave into our topic. So then I'll give you a reaction. It's this. And it also gives you that the equilibrium constant is 108 at 25 Celsius, which is the standard temperature yeah. So first of all, I want you to write the reaction quotient expression for this reaction. So pause this video and try yourself and then go back and watch again. Okay, are you done? Oh, let's go together. So they're given to you as this reaction. So remember, how do you write the reaction quotient expression? It's always product over reactant. And so in here we have the concentration of the product over the concentration of the reactants. And remember, the reactants, it's always times, like it's always multiply. It's never gonna be plus. I have a lot of students every year who miss this question a lot because they thought, oh, you have to add the concentration of the reaction or products together. It's not work that way. Okay, so I forgot one thing is that the concentration of Cl, you have to raise to the fourth power. Why? Because when you're writing the reaction quotient, whatever the coefficients in front of the reactants or products, it have to become the power when you're writing the reaction quotient or equilibrium constant. Okay, so they're working in the same way, but they're defined for different meanings and using in different situations, which we'll talk about later. Okay, and then the second thing, it says a reaction vessel contains 0.100 moles of cadmium ion. So which means that this, and then 0.500 moles of chloride. So it's this, and 0.250 of tetrachloric okay, so this is a very long polyatomic like a pronunciation. I will try my best, but I'm not sure if it's correct. Correct me if I'm wrong. Okay, thank you. So this will be this. So okay, let me try again. Tetrachloride cadmiate ion. I don't know. Is that sounds right? Sorry. Okay, so it basically gives you all these informations. So this is part B, this is part B, and this is part A. Okay, and it says predict the direction the reaction must shift to reach equilibrium. Show a calculation to justify your answer. Okay, so this is gonna leading to a very important topic right now. So first of all, I want you to calculate, like recalculate again for the reaction quotient. This time, plug in the numbers that they're given to you into the reaction quotient expression. Okay, pause this video and come back later. Are you done? Okay, let's work together. So Q is equal to 0.250 moles divided by 0.100 mole times 0.500 mole raised to the fourth power, and it equals 40. Okay, so it asks you to compare the Q and K. So the K given to us is 180. So 40 is less than 180, which means Q is less than K. Well, what does it tell us? Well, it actually tells us a lot, and that's the topic that we're gonna dive deep right now. Okay, so then Q versus K. So what does it mean? Well, remember K is referring to equilibrium constant. So this is a constant, so it works for like a every state's equilibrium in the reaction. Like a reaction can have infinitely amount of times for it to reach equilibrium state, but whenever it reaches equilibrium state, they will only have one equilibrium constant. However, the reaction quotient just measures the instantaneous. It's like the very it's like that moment, like the ratio between the products and the reactants concentrations. Okay, so just remember these two. Like this is temporal and this is constant. And so when we're comparing these two variables, and in other way, like when we're really doing this questions, it actually compare these two numbers, and there's actually leading us to three different situations, and I'll show you right now. So first of all, when Q is greater than K, which means that the current products is gonna greater than the reactants. Well, what does it mean? Okay, remember Q is equal to products over reactants. And when the Q is greater than K, so for example, like we assume K is equal to 1, so P is equal to R, like a products amount of like the concentration of products is equal to the concentration of reactants. But however, in this case, this is greater than 1. So what does it mean? Well, the numerator must have to be greater to let the whole numbers to be greater. Okay, so which means that in here, temporary we have more products than reactants, which means that according to Le Chatelier principle, the whole reaction, the whole equilibrium have to shift left. Well, because of what? Because remember, reactants it's in the left side and the products is in the right side. When you have more products, which means that the right side is gonna be more heavier. So so think about that like a teeter-totter. Like when you have more heavier in the right side, which means that teeter-totter will like go this way, and when you using the Le Chatelier's principle, you have to balance this equilibrium out. By balance this equilibrium out, you have to shift the whole thing to the left, okay? So thinking about that way, like always use something that it's simpler for you to understand in your mind. Like this can be different and varied for everyone. So it's okay. Okay, just remember how this logic works behind the theory. So which means that this is gonna favor the reverse reaction to achieve balance. Okay, and there's another another situation which is Q is less than K. Well, what does it mean? Well, it means that again Q is equal to P over R, and R must have to be greater than P to let the whole fraction to be smaller. Okay, so if you like for example, if you like use this 3 divided by 2, and it's definitely gonna be larger than the 3 divided by 4. Okay, think about the logic behind it. So then it means that currently we have more reactants. I'll just use the abbreviation here, and which means that according to Le Chatelier's principle, in order to let the whole equilibrium reaction go back to the equilibrium, the whole reaction have to shift to the right, which means it favors the forward reaction. Okay, and one last thing. When Q is equal to K, well, think about that. What will that happen? Well, it means that the whole reaction equilibrium is actually at equilibrium, okay? So nothing have to be shifted in here. It's actually at equilibrium already. Okay, so after knowing these three theories, and most importantly is that knowing the logic behind each of them, we can go back to the questions and trying to solve it. So then we already know that In this question, we calculated Q is less than K. Well, according to the three different scenarios in the bottom, which one do you think will fit in our question, and what should the whole reaction equilibrium do? Well, the whole equilibrium should shift to the right, because it corresponds to this, and it will favor the forward reaction. Okay, so according to this video, I would like you to know the relationship between Q and K and how do you calculate them and how do you use them in the question. I used a question as an example to lead you into this topic, into this theory, and most importantly, let you understand the logic behind the theory. And after you knowing this, I think you're in a good shape for your next quiz or exam. So good luck on all of your tests, and I hope this video helps a lot. You understand a little bit between Q and K and how to use the Lechalets principle to logically apply the principle into these questions. Okay, so that's all for this video. I hope you have a nice day, and I'll see you next time.